Okay, section 10.1, the Cartesian coordinate system. Basically, we're going to get into graphing. Okay, this might be new to some people. I don't know if this is going to be reviewed from another class, but this is kind of one of the things that is one of the bases of, not English teacher, of algebra. So let's just kind of look into our objectives here. Related ordered pairs of real numbers, use an equation in two variables, plot them, and then we're going to find ordered pairs that satisfy an argument or a statement, and then identify points on a graph. Okay, go through some notes here, just kind of some basis, and I'll try to explain it. Okay, there is a one-to-one correspondence between points in a plane. Okay, some very interesting words here, word choices, which are very important for us. I'll kind of come in here and highlight those. Okay, there's a one-to-one correspondence between points in a plane and ordered pairs of real numbers. Okay, one-to-one means you have a point. Okay, like say here, we're going to draw a graph. You're going to see this. If I have a point right here, this one-to-one means I have a point here, and I have to find it, I have to have another point here. So this is a one-to-one relationship, because nowhere else is that point ever going to exist right there. If I wiggle this A back or forth, or I move this B up or down, notice I'm going to have different points, and it's not going to match right there. That's what that means. And then here you have the y and the x-axis. Okay, and this is called a plane, okay? Or more important, the Cartesian coordinate plane. So let's continue on. Although this discussion is related to ordered pairs of real numbers, most of the examples used are integers. Let's remember what integers are. Okay, I know our brains tend to forget, but remember integers start with the little z here, little, I forget what kind of script they call that. But remember, put that in brackets, you got dot, 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 -3, -2, -1, 0, 1, 2, 3, comma, dot, dot, dot. So notice here, you're not seeing fractions. These are all whole numbers, except for, we're going to the negatives and we can include 0. So that's what integers are. Okay, so we're going to use easy numbers. Let's put it that way. Why? Because ordered pairs of integers are relatively easy to locate. Okay, anything else, it gets real hard, mainly because, like it says here on the next point, because of the dots we're using. Okay, well, what if I have a line and then there's an answer like right next to it? Well, that dot's going to cover up a spot I need to be at. So we're going to be going for perfect points right now. Let's do an example here. Plot or graph the set of ordered pairs. Okay, here they all are. Okay, notice they said a set. They're putting all of these inside of braces. Okay, we could call this set something over here. So we got A of 2, 1. Let me get a pen out here because I want to make sure you realize something. That every single one of these is a point. Okay, so this is like point A, point B, point C, D, E. All of these from now and forever. Okay, these are always going to be X, Y. If we're talking about coordinate points, okay? X, Y, X, Y, X, Y, X, and Y. Okay. Well, we're going to plot each ordered pair. The origin, 0, 0, for the X coordinate, move right if positive, move left if negative. For the Y coordinate, move up if positive, move Y down if negative. You're going to see. I'll point all these out to you. So let's look here. For the point A, -2, 1, we always do the X first. So I'm just going to come in here and use a highlighter here. Change my size. Okay. Looking here for 2, 1, remember, this is your X value. So we're going to come over here, and I'm going to go negative. In fact, let's go ahead and write this down here. This area of your graph is always going to be positive, positive. Here, because I went positive, and then I go up, and that's positive, because we always go right or left first, and then we go up or down. It's always that, okay? Here, it's negative, positive. Here, negative, negative, and here, positive, negative. Okay. Notice we have a -2, so let's come over to -2. In fact, I'll use this. We'll come over here, -2. And then we're going to go up by 1. And there's our point A. Okay. For B, we go to -2 again. But instead of going up, notice now we're going to go down because that guy right there is a negative. So we're going to go down. 1, 2, 3, and 4. There it is. And if you look very carefully here, notice I show negative, negative right here. Well, look right here. I have negative, negative. Okay? 0. Okay, well, 0 is right here. Okay? This point right here is also what they're talking about being the origin, which is 0, 0. Okay? It's the points where the main point, where they connect. Okay? That is their center, that is their origin, that's where everything comes from. Okay? So here, starting at 0 and then just going up to 4, okay, we got our point C. And then for D, we can go to 1, 3. Well, that's a positive 1. And then 1, 2, 3. That's up 3. Okay. And then for the E, we've got 2, negative 5. Well, that's a positive 2. So that's that guy there. And then negative. So I've got a positive, negative. That means I'm going to be in this area. Well, positive 2 and then 1, 2, 3, 4, and 5 gives me the E. And so pretty straightforward. You practice this enough, it becomes really, really quick. It's going to become very second nature to you, so don't stress on this. Okay, find the missing coordinates in the ordered pairs so that each point will satisfy the equation. Well, here's the beauty of graphs, is what this does is when in a linear equation, it's helping us solve. So notice here, they're saying, hey, x is equal to 3. Well, look, there's a coordinate point there. This is our x value here. Okay, well, they're saying x is 3. Well, let me take this, and remember, we can replace this x with 3 and rewrite this as 2 times 3 plus 3y equals 12. Well, 2 times 3 is 6 plus 3y equals 12. That's a positive 6, so how about we subtract 6 off both sides? That gives us 3y equals 6, divide by 3, and we get y equals 2. Well, now we know that the y for this would be 2. So if we plotted this on a graph, okay, we'd plot 3, 2, and then we could come in here and go, okay, well, 3, 2 satisfies this equation. If I plot these 2 points into this, I will always get 12 at this point. Okay? Same thing, we can do the exact opposite for negative 2 over here. Okay, so watch. 2x, well, plus, well, notice I have a negative 2 now, equals 12. Oops, I was about to put negative 2. Looking ahead, okay, equals 12. Notice we're still using the same equation here. Okay, there's a reason for this. You'll see this at the very end. So I've got 2x plus, well, that's not going to be 2x plus, that's going to be 2x plus negative 6 equals 12, which is the same thing as saying 2x minus 6 equals 12. So let's add 6 to both sides. Okay, that's going to give us 2x equals 18. Divide by 2 off both sides, and we get x equals 9. There we go. So here, 9 satisfies this. And what this does, this line right here, you're going to start noticing, it creates, okay, later on, you can plot all these little points on a graph, okay, and it'll create a line. And these are just some points on that line. Okay, so let's kind of continue on here. For the ordered pair 0, negative 2, let x equal 0 and y equals negative 2. It's literally just saying plug everything in and see what it does. Okay, well, let's plug it in and see if it's correct. Let's check here. Well, my y is negative 2, so let's replace that negative 2 there. Equals what? Well, I've got 3 times what? Okay, well, my x is going to be a 0. And then I got minus 2. Well, negative 2 equals, well, 3 times 0 is always just 0. Minus 2. Well, 0 minus 2 is negative 2, so negative 2 equals negative 2. This checks out. Those points do work to satisfy that right there. Now, had you done this and it didn't work out, then of course you have something that's not a point on that line. Okay? Let me show you what I mean. So we have a point here, or we have a line. Okay? And it says, the graphs of 2 lines are given. Okay? Each line contains an infinite number of points. Use the grid to help you locate or estimate 3 points on each line. Well, I only pulled off one of the graphs, but let's look at this. They give us some very, very nice points here. So let's start looking at here. They give us a nice line, let's put it that way. Because if you notice carefully, everything crosses over these perfect little pretty points where the grid lines connect. So that's where you're going to want to find your points. Don't start trying to look in here. It's not going to work out for you. I promise. Okay? So you come in here, and let's always do your x first. You can go either way. Let's do a positive first. Let's say I just come over here to 1. Okay? Well, I come over here to 1. Well, one of my points is going to be a 1. And then let's go up. 1, 2. Well, there's 1 point right there. Because notice it's on the line. Well, how about let's go over here to 4. Okay? Well, I'll go to 4. That's going to be 1 point. Remember, that's going to be my x value. So I'm going to put that there. Put that there. There's a y. There's a y. Okay, and we always separate these by a comma. Close them in with parentheses. Well, let's go up. 1, 2, 3, 4, and 5. There we go. There's a point. Well, let's go the other direction. How about we go to, let's go to negative 3. Well, here's 1, 2, and 3. Okay, well, that's going to be the x is going to be a negative 3. Well, what's going to be my y? Let's go down. 1, 2. Where am I at here? We come over and look, and I'm at negative 2. And that's about straightforward. Notice this one right here that we just walked right over. Notice that one stopped right there at where x equals negative 1. Well, you could also put that down. You could put negative 1. What would be the y value there? Well, notice if this is the y of 1, this has to be y equals 0. And there we go. Gave us 4 points on this one. All right, we'll do some more in Hawk's examples, but this is pretty straightforward. Should be a pretty quick homework, actually.